In this video, we're going to be showing you how to use the Neurosnap Pipelines feature to allow you to combine different tools and services on Neurosnap, as well as route outputs and inputs from these different tools. For those of you who aren't already aware, Neurosnap is an online platform where you can access a variety of different computational tools for research in molecular biology, bioinformatics, and cheminformatics. And essentially what this pipeline feature is designed to do is it's here to kind of facilitate the interactions between these different tools. There's a lot of times we want to use these tools on the same data, or we want to route inputs from one to another. So it's kind of there to make things more straightforward to actually achieve this by also providing a graphical interface instead of having to implement this feature programmatically. So for instance, one such example is like a virtual screening where you have a bunch of different molecular docking models for protein ligand interactions. So that's one such example. Another one would be something like molecule properties. If you have a list of small molecules and you want to evaluate different properties for them. Another example that we're actually going to be reproducing from scratch is this pipeline over here for virtual screening as well, where you start off with some amino acid sequences to predict the structure for using AlphaFold2. And then after that, you're going to take this structure, get the best rank 1 structure, and then feed it to DynamicBind, which does molecular docking. We can also provide a list of different ligands over here as well to go from. So to create a new pipeline, what we'll do is first we'll just blank out this pipeline and reset things. And then after that, what we're going to do is we're going to add the different nodes that we need. So the way pipelines work is you have input nodes and output nodes, and you basically specify the connections between them. And in our case, what we need is we're going to need a protein sequence list as well as a molecule list to have our inputs and specify those. And then next up, we also need this logical operator, which is the job file select node. And this is going to be responsible for fetching produce files from AlphaFold2 and routing the appropriate ones to DynamicBind. So next up, we actually need DynamicBind and AlphaFold2, and what we can do is we can go grab them over here. And then for DynamicBind, we can actually go ahead and grab it over here as well. So next up, now that we've actually gotten all the nodes that we need to basically set up all the different connections. So the first thing that we need to do is we need to actually get the proteins that we want to use, or in some cases the protein. So for this particular example, we're just going to use the example sequence over here, which is P06278. So P06278, and we'll go from there. So this sequence is going to get its structure predicted by AlphaFold2. We can actually configure some of the settings on AlphaFold2, like for instance, if we wanted to adjust the recycling steps or modify the MSA mode or something like that, we have the option to configure that over here. After that, what we want to do is we want to ensure that the rank 1 structure produced from AlphaFold2 is the one that's getting propagated to DynamicBind, which we're going to connect right over here. So what that means is, AlphaFold2 produces 5 different PDB structures by default because it has 5 different models that are being used on Neurosnap. And essentially, we want to take the best one out of that bunch. And since it's a PDB file, we need to specify that over there. Conversely, if it was a ligand, then we need to specify an SDF file over here. And generic file as well for generic files. And then finally, we want to collect the molecule list node over here as well. So for molecules, we have the option to upload them. So for instance, this is an example structure that I've uploaded. You can also enter the CCD code, or you can enter a SMILES code corresponding to that ligand. So for instance, if we wanted to enter something like this, or something like this, we have that option over here. This is entered by the CCD code. And then finally, we also have the option to search for the molecule directly on PubChem. So for instance, we could use aspirin over here. If we want to use something else, like, something with, I don't know, cyclo in the name, we can go through that and we can search for different results using the PubChem database. And then once it resolves that, it will appear right over here, though it might take a little bit longer depending on your search query as well as, your internet connection. So now, we finally have the results. I think what we'll do is we'll select this one over here just for fun. So now that we have a couple different molecules that we've selected, we'll actually go ahead and run the pipeline, and we'll give it a name. We'll do demonstration pipeline MD. We'll be a little bit more descriptive. We'll do AlphaFold2 MD, and then after that we can hit run pipeline. It'll take a little bit of time to upload everything, and then after that it'll actually go ahead and produce all different jobs that you need for this pipeline. So let's take a look at the results panel. Essentially what it's going to do is it's first going to create the different jobs necessary to run the first layer. In our case, the first layer is going to be AlphaFold2. Once that's done running, what will happen is the DynamicBind jobs will start to automatically populate within this table over here. Additionally, if any errors occur, so for instance, if there's an error in the routing or one of the jobs fail, then the error will get added to this table over here. Additionally, once the jobs are complete, you have the option to aggregate them. So for instance, some tools and services, they might output a CSV file or they might output like a JSON file. What you can do is you can select that different node. So for instance, like let's say DynamicBind produced the CSV file that we want to aggregate across the different entries that we had for each different molecule. We can go ahead and enter that over here. Finally, we also have some other information like the descriptor. We also have the template code. So if you want to share this template code or use it again, you can just copy this, as well as the pipeline ID and so on. So what we'll do is we'll wait a little bit for the AlphaFold2 jobs to actually complete. And then after that, once the DynamicBind jobs are prepared as well, we'll come back to this results page. All right, so we are now back with the results, and as we can see, every single job completed successfully, and we know this as well because the error table wasn't populated at all. And the nice thing is we can actually download all the data produced by all these pipelines, and you'll get like a nice organized zip file as well, should you choose to click on this button over here. What we can do is we can also take a look at some of the jobs that were produced. So starting off, we have the original amino acid sequence that we had. As we can see, the structure was predicted quite well, and the only region that's predicted with low accuracy is this region over here by the terminal, which is pretty normal as these regions tend to be less conserved and more disordered in general. And this is the rank 1 structure, but as discussed previously, AlphaFold2 predicts a couple different structures. So this is rank 2, rank 3, and so on. As we can see in general, the structure was predicted with pretty good accuracy overall. So additionally, we can take a look at the different DynamicBind jobs that were produced as well. What we'll do is we'll just load them up right over here. And as we can see, for this particular ligand, it was docked over here onto the protein. And in this case, had a similar pocket over here, and so on and so on. So every single job gets produced, and the inputs and outputs are quite literally just there. And then finally, what we can do is if we really want to, we can use the aggregation feature as well. So the aggregation feature only really makes sense to use on DynamicBind right now because every single DynamicBind job should produce one of these CSVs over here. So if we want to just go ahead and instead of manually downloading each one and organizing them ourselves, we can just enter the name of the file over here, set this to DynamicBind, and then we can aggregate the files directly. So what it'll do is it'll go ahead and automatically download them, and then you'll have a CSV file with everything, including the job IDs and whatnot, available for download. Then you can inspect that later on. So I hope this tutorial has been helpful. If you have any question or if there's anything else you want to comment, please feel free to leave so down below, and we'll be more than happy to get back to you. If you like the video, please feel free to leave a like as well, and enjoy the rest of your day.